covered under the biceps. So this is median cubital. This one or this one, it doesn't matter. The connection between cephalic and basilic. This is median cubital. I believe that's enough for this hand. Now the lower extremity is different. The lower extremity, the aorta ends at L4 vertebra, by dividing into right common iliac artery and left common iliac artery. Common iliac. Common because it will give branches. Each common iliac will give external iliac and internal iliac. Internal iliac is short and supplies organs in the pelvis. Male and female. Organs of the pelvis are supplied by internal iliac artery. External iliac artery will pass deeper to inguinal ligament, and the inguinal ligament is running here. This is inguinal ligament from pubic symphysis to anterior superior iliac spine. So when the external iliac in the pelvic cavity here passes underneath inguinal ligament, we call it femoral artery. This is femoral artery. And this is femoral vein. The big one is femoral vein. Once blood is returning back to the heart, once it passes underneath inguinal ligament in pelvic cavity, we call it external iliac vein. So internal iliac artery is accompanied by external iliac vein. Femoral artery is accompanied by femoral vein, and so on, because they run back to back. Common iliac artery is accompanied by common iliac vein. So this is common iliac artery. If we take this, that's common iliac artery. Now this is common iliac. This is femoral artery. Did I say common iliac? Sorry guys. Where is the thigh? That's femoral artery. That's femoral vein. Femoral vein. Do you see saphenous vein? Saphenous vein begins from the big toe here. Here. Don't resist. Of course, I saw on your lab manual that's the big toe, and this artery here is called the dorsalis pedis artery, between first metatarsal bone and second metatarsal bone. This big one is dorsalis pedis artery. Usually, the doctor will check pulse in dorsalis pedis artery in the dorsal aspect, superior aspect of the foot in diabetic patients. If there is pulse, then there is blood going to the toes. So there is no fear of gangrene. Gangrene is tissue death, because diabetes causes microatherosclerosis. Microcirculation of blood vessels, capillaries, they get obstructed, and it decreases feeling. So the patient will not feel, and the tissue is dying gradually, and we call it gangrene from diabetes. So if the doctor feels pulse in the dorsalis pedis artery, it is okay. They also do Doppler ultrasound on lower extremities. If there is patent blood vessels, that's okay. If they are occluded, partially occluded, they do bypass surgery. They replace the arteries to restore blood supply to the feet to avoid gangrene. That's in diabetic patients. Now, do you see from the side of the big toe, do you see the great saphenous vein, great saphenous vein, great saphenous vein, great saphenous vein, that's superficial vein. Great saphenous vein, great saphenous vein, great saphenous vein. It drains into femoral vein. This is deep femoral vein. Do you see how saphenous vein, this one, and that's the continuation, drains the blood into deep femoral vein, it becomes a femoral vein, and now it enters into pelvic cavity. We call it external iliac vein. It joins internal iliac vein. They make common iliac vein, the right and left common iliac in the pelvic cavity at level L5. They join to make the beginning of inferior vena cava. So inferior vena cava is bringing venous return to the right atrium from all the body below the diaphragm. Because superior vena cava is from all the body above diaphragm. So on this model, you need to see the saphenous vein, which is called the great saphenous vein. In your book, it says great or just saphenous vein. That is great saphenous vein. And it drains the blood because blood is returning to the heart. So veins drain into a bigger vein. Blood is joining, veins are joining to make bigger veins. That's why I'm saying drain. Drain blood into a bigger one. Great saphenous vein drains the blood into femoral vein. And the femoral vein passes below inguinal ligament. We call it external iliac vein. Same blood vessel. It changes the name by location. Like when we drive in the streets here, the street has a name, and suddenly after a traffic light, it changes the name. Why? Because that's another city. They give the same street another name. It happens a lot. Our body is doing the same thing. No. Our body didn't name itself. The people who named the anatomy did the same idea. Okay? We don't have an upper extremity like the veins and arteries of lower extremity like the one we have for upper. But on this one, on this foot, I showed you dorsalis pedis artery and the great saphenous vein and femoral vein. These are the ones that I think can be a test question.
There's anterior tibial and left popliteal.
Popliteal.
And femoral. It's page 14.
Oh, don't get it. Oh, the very last. Oh, great saphenous vein. Okay. Anterior tibial vein becomes popliteal vein, becomes femoral vein. So in the lower leg, there is anterior tibial vein. In the back of the knee, we call it popliteal vein. And then when it goes up in the side, we call it femoral vein. When it is joined by great saphenous, we call it external iliac vein. Actually, great saphenous joins femoral, but we put it here as great. Femoral will become external iliac after it enters pelvic cavity, after it passes below inguinal ligament. I never tagged anterior tibial or popliteal. I always tag, even in the Rayo cadaver, I always tag femoral, great saphenous, external iliac, internal iliac, common iliac.
So
And
will you be adjusting the lab exam, or is it?
Yes, for stuff like that, I would adjust it.
Okay. So can you please
But the reason for exam 2 was we didn't dissect the eye or the sheep heart. It was heart, right? It was brain.
Mm-hmm.
The brain.
And all questions about the heart and the eye was on the sheep eye and the sheep brain. So I decided, to be fair to you, to put the same questions but on models. That's why I made a change. And the same thing for, I felt that you didn't have enough time to review the slides, so I left only 2 microscopes, and I removed another 4 or 6 microscopes because there were a lot. And I replaced them with models or something, But we have enough time now. Many of you don't attend the lab, it's your problem. There are slides, and if there are like 8 microscopes with 8 slides in the exam, I will not replace them. You need to know that. What slides? They are in your lab manual. You have the microscopes and you have the slides on the benches, review them. You have enough time, you have 4 weeks.